Welcome. In this video, we're going to determine whether the limit of 1 divided by quantity x plus 1 squared as x approaches negative 1 exists. And we're going to do this by graphing, and we're not going to use technology. We're just going to use what we remember from function transformations about how to graph this. So if you recall from maybe a previous course, maybe pre-calculus, if we have, say, f of x plus a, this shifts the graph to the left by a units. Okay, so I have x plus 1 here. So in that case, a is equal to 1. So I know I'm shifted to the left by 1 unit in this case. Now, what is f of x in this case? The unshifted version of this is f of x equals 1 over x squared, and that looks something like this. So if you notice, this function blows up to infinity right here at the y-axis. So now we want to shift this 1 unit to the left. So rather than blowing up to infinity about the y-axis, it's going to blow up to infinity about the line x equals negative 1. So here you can see the graph of 1 divided by x plus 1 quantity squared in blue. And I also sketched out in this green dotted line its vertical asymptote. So now let's use this to evaluate the limit. Well, as we can see, the limit as x approaches negative 1 from the left of this function. So that is, as we approach the negative 1 along the x-axis from the left side, this function keeps blowing up to positive infinity. All right, so now let's look at the limit coming from the right-hand side. So the limit as x approaches negative 1 from the right-hand side of 1 divided by x plus 1 quantity squared. Well, that also approaches positive infinity. And I'm going to remove this plus sign. I'm being a little redundant there. So it's also blowing up to infinity. So what can we conclude? The left and right-hand limits coincide. So we can write the limit you see here, and we say that f of x grows without bound as x approaches a. This doesn't actually mean that this limit exists. All we are doing here is describing the behavior of this function, and this tells me that this function behaves in a way that it blows up here at x equals negative 1, but we are not saying the limit actually exists. In fact, this is one way for a limit not to exist, since in order for a limit to exist, we need it to actually approach some finite value. So again, this limit does not actually approach a finite value, so it does not exist, but the notation helps us describe the behavior as we approach x equals negative 1. I hope this video was helpful.